Hi friends, welcome to Cloud Native Data Management Days as a co-located event in KubeCon Europe 2021. Good morning, good afternoon, good evening, wherever you are. Today in this session, we will be discussing about Unified SODA CSI plugin for heterogeneous storage management. With me, Mohammed Asif. Asif?
Yeah. Hello, everyone. Yeah, my name is Asif, and I'm a maintainer at SODA CSI SODA Foundation. I'm also an ASF member and Apache IPMC. I work as a senior system architect at Huawei.
Hey, thanks, Asif. So myself, Sanil, I'm part of the TOC and architecture work group of SODA Foundation. Thanks for joining us today. So I will go through first short introduction on SODA Open Data Framework, and then we will talk about the CSI specific part on SODA, and finally on SODA CSI plug and play, one of the key features which we are working on now. So SODA ODF is Open Data Framework. It's a completely open source software under Linux Foundation. SODA Foundation is under Linux Foundation, just like CNCF. It we try to our envision with this platform is to connect data end to end, whether it is for cloud, edge, or on premise. So basically, our idea is to have a data framework to connect any platform like Kubernetes, OpenStack, VMware to any storage, be it enterprise storage or open source storage or cloud storage. In this diagram, the cloud storage is not there. It will come in the subsequent diagrams. And the key propositions are it is completely open source, so it prevents vendor lock-in. Connects data silos because, as you know, different data management solutions with the different vendors, vendor-specific solutions. So we try to provide all data management solutions under the same framework, and scalable, of course, extensible. And we also work with the different ecosystem partners on hardware, software solutions and services, and also standard organizations like SNIA. And we also plan to have some kind of a compliance on the support of storage in SODA ODF going forward. Let's see a very simple view of SODA Open Data Framework. So we try to provide a unified data management API layer, and then we have a controller to manage the metadata policies, configurations, and something similar to that. And on the core, we support file, block, and object. Then finally, we have a storage backend manager, which can help to connect storages, heterogeneous storages at edge or core or cloud. So predominantly, we are currently working on the core, the on-premise part, and also on the cloud part. So as I mentioned, it's something like any platform to any storage with any type of storage and different kind of storage management. This is what overall the framework look like. This framework is kind of a logical view. How do we meet all these features requirements is through different kind of projects. So we have different projects. We have projects on multi-cloud. We have projects on-premise to manage heterogeneous storage, and we have projects on heterogeneous storage management, especially on the monitoring side itself. We have a separate project. So to see the project architecture, you can see here we have on the northbound side, sorry, we call it as northbound platforms, which are connected to open data framework through northbound plugins. So we have connector or plugins for OpenStack, Kubernetes, or VMware, and then it goes through the API layer and controller multi-cloud. Multi-cloud is specifically to connect the multi-cloud backends, the different multi-cloud vendors, and the dock is to connect the heterogeneous storage on premise, and the storage infrastructure manager, which is called SIM, The project name is Delphin. This takes care of heterogeneous storage monitoring part. So some of the key features of the ODF framework is policy-based storage provisioning, a dynamic Kubernetes persistent storage with SODA CSI. That is a unified SODA CSI, which we are going to discuss in detail today. And different cloud backends, different storage types, file, block, and object, and the monitoring. And we also have anomaly detection, especially on the monitoring part. We can connect through Kafka uh, to any of the anomaly detection engines. So we can do anomaly detection, and more intelligence can be built on based on the monitoring data. Now, on specific to CSI, so we have a single SODA CSI plugin to manage multiple heterogeneous third-party CSI drivers. So it can support different storage vendors. Basically, it abstracts the multi-vendor heterogeneous storage, and we have provision. We can provision Kubernetes persistent storage dynamically with storage class and profile mapping. Any CSI storage, this is one of the modifications what we have done in the initial SODA CSI plugin. We can right now do CSI plug and play. The third-party drivers can be plugged without any modifications to the driver. And going forward, we also started working on intelligent provisioning, orchestration, monitoring under the CSI, and also the data protection features, along with hybrid data management. Especially, we are starting now in the next release onwards that from on-premise to cloud snapshot kind of feature with respect to CSI. So if you see on the right-hand side, you have the CSI, and then we are focusing on four key aspects: dynamic provisioning, storage orchestration, performance monitoring, and data protection. So data protection is one thing we are trying to focus in the upcoming release. So CSA is one of the key focus areas for us going forward, because Kubernetes is one of the key platforms which we support from the northbound side. So Asif will take us through the CSI and the CSI plug and play, what we are planning to do and what we have right now. Asif?
Hey, thanks, Anil. Thanks for explaining the complete SODA and how CSI will be used. So I just want to give a brief introduction of what CSI is. So CSI is like a spec which is used to expose block and file storage systems to CO workloads. And using these CSI specs, all the storage vendors can basically write their drivers and plugins for their specific vendors, for their specific storage stacks. And then those drivers and plugins can be used in Kubernetes to provision the storage for the containers. Yes. So when we say data on Kubernetes is basically we have the storage class, and these storage class basically holds these informations about which CSI controllers needs to be called for provisioning. These CSI controllers are basically the drivers and the plugins written by storage vendors, and which connects to their hardware stack. And then we have the PVCs, which are basically persistent volume claims, and we have the persistent volume. So these CSI controllers helps to provision the PV and PVCs. So if we have multiple multiple CSI, like say we have an IBM driver and a NetApp Trident driver. So in those cases, we will have two storage classes, and these storage classes will hold the information of their individuals uh, drivers, and they will have their own configurations. So basically, the same storage class cannot be used to provision multiple PVs of different vendors. So going ahead. So these are the challenges when we use CSI with heterogeneous storage. Like user needs to create a different storage class for every new storage uh, vendors and drivers, and they need to configure all the hardware required configurations in the storage class. So when the user repeatedly switching between different storage vendors, it becomes a difficult task for them to migrate from one storage vendor to another storage vendor, as there are a lot of learning curves, and plus the storage class needs to be updated every time. So these are the challenges for heterogeneous storage management. And seeing this, we have like what CSI plug and play offers is, like we try to make a single CSI, a single SODA CSI provisioner, okay, which can be used to provision storage for multiple drivers with the same storage class. So when user is switching between two different storage drivers, they don't need to change anything, they just need to change the profile ID. And also SODA CSI plug and play features offer is like they SODA CSI plug and play can automatically detect which driver or which backend driver will be the best suited for this type of request, and based on that it will provision. So to implement this, we have SODA CSI plug and play. And for that, if we see the diagram on the right hand side, this is the typical CSI driver deployment diagram, where we have the TP controllers and the TP node in each pod. And these pods have multiple sidecars, which are basically provided by Kubernetes CSI org. And these sidecars helps to connect to Kubernetes API server and gets the provision request. So any vendors, any storage vendors, they develop only the TP controller and TP node, and all of these sidecars are provided by CSI. So what we did to implement these features is like we tweaked these sidecars to get the inbuilt functionalities of SODA. So when users tries to use this plug and play feature, they don't need to change anything in the TP controller. TP controller is basically the third party controller, which is like the storage controller, which will connect to which will send the request to the hardware stack to provision the request. So so that's the reason we call it plug and play, as like we just plug in these SODA CSI provisioners into the pod, and then you will be able to get all the SODA features, and there is no change, not even a single line of change in the third party drivers. And how do we determine which TP controls, when there are multiple TP controllers in the single deployment? How do we determine like which TP controller should be called is using the SODA profile ID. So this SODA profile is basically holds the information of like what type of storage is required for the provisioning, and like what should be the SLA parameters, or like what should be the input and output thresholds. So based on that, it determines which backend needs to be called for provisioning. And once this SODA CSI provisioner is plugged into the same pod, it gives all the functionalities of like monitoring and telemetry and observability of all the provisioning requests which are happening. So next slide. So if you see the typical call flow for this type of a SODA CSI plug and play feature is like a user sends a request for provisioning to Kubernetes API server, and Kubernetes API server updates these requests, and then SODA CSI provisioner keeps watching for the PVC objects with the provisioner name as a SODA CSI. So this SODA CSI provisioner watches for these objects, and once it receives the object for the creation, it basically updates these requests to SODA API server. So here what we see is SODA API server and or the SODA is completely a different entity, and Kubernetes is completely a different entity. So all the intelligence is provided by the SODA. So these CSI provisioner have interacts with SODA API server to get all the required information, like which profile, what are the profile parameters, and based on those parameters, which backend driver needs to be called. So based on those intelligence with the TP controller to provision the request. Next slide. Okay, so what advantages we get with the soda once we do a plug and play for the soda? What advantages we get is like users can switch between the different heterogeneous storages with just changing their SLAs in the soda profile. So if say a user needs to switch from a vendor one to vendor two, and the vendor two input and output threshold is less, so if the applications can bear that threshold, so they can just change the profile information, and the soda CSI provisioner will automatically migrate or change to a different vendor. And users can also monitor and manage different heterogeneous storages for their container in a unified way. So what we mean over here is like the monitoring and management for different vendors are in a different way, and but if we use this plug and play, like the monitoring and management capabilities will be unified over all the vendors, and it will remain same whether it's a vendor one or vendor two. And this is a very simple design which lets you patch the existing deployment without doing any changes in the actual CSI drivers. So it's like it's easy to maintain even if the the third party CSI drivers upgrade. So it it will hardly do any changes to your current deployment. Next. This is a big feature what we are doing, and we are basically integrating and testing with a lot of storage vendors. Here is the roadmap. Like right now, we are trying to coexist the different storage drivers in the same deployment with Soda CSI Provisioner as a pluggable feature. And we are also trying to build a system metadata sync system by which we will be able to sync all the required informations, all the required storage informations between Soda and KTS. And the roadmap is like Soda should automatically or dynamically choose which drivers are required for each request. So currently like these informations are present in profile, and right now it cannot dynamically like migrate from one vendors to other. But going ahead in our next release, like these all features will be available. And also will provide the Soda CSI provisioner will also provide the disaster recovery solutions in a unified way across all the heterogeneous drivers. So so that's all from CSI plug and play.
Thanks, Asif. And
Audit.
also, just one more point to add is that on the CSI part, we are also extending the heterogeneous monitoring solution which we have. So as of now, it's outside CSI. As I mentioned, it's called Delphin project, which support heterogeneous storage monitoring for resource alert and performance metrics, which we plan to integrate with the CSI solution so that we can also extend the CSI monitoring capabilities. That's what we have today for this session. And just before we closing, we have the Soda Foundation global event called SodaCon coming up. There's a second edition of SodaCon, the global event. It's in July 13 and 14. The registration and also the call for papers are open. The link is on the right hand side. So please join us. Uh, so last year, December, we had a big event on SodaCon. So this is mainly on data and storage, open source. And we have also given our project GitHub. All our projects are present in Soda Foundation GitHub and the documentation. Please join us in the Slack. We call for contributions as well because we are working in multiple areas of data management across the board, cloud, on-premise, and even the edge part. Please join us. And we also have initiated under Linux Foundation a data and storage survey. It's an industry survey to understand what are the key trends in data and storage. So the link is given here. Please join, and till May you can uh, give your valuable feedback on that. That's all from our side for the session. Thank you so much for joining and listening to us.